Good morning, everyone, and welcome back to the fourth and final session in the introductory Python course. Appreciate you sticking around and hoping you're getting some value for your dollar. Well, it's a free course, so it's pretty good. It's infinite value. So yeah, let's get started. So I'll just post a link to the Etherpad again in the chat. And yeah, I have a link there for my day 4 notebook that I'll be working in today. If you want to refer to all the stuff that I'm doing today, you can do so. So last time we finished off with looking at pandas and all of the things that pandas can do for data analysis, in particular tabular data. So we downloaded some CSV files and loaded them into pandas and manipulated the files and filtered data. And and so the first topic that I'd like to look at this morning is plotting. So I'm going to start sharing my screen. I don't know if you can hear a dog in the background, but someone came to the door, and if my wife doesn't answer the door pretty quick, I might have to go deal with it. But anyways, yeah, so let's talk about plotting. So the most popular and the most widely used scientific plotting library in Python is called matplotlib. It's been around for probably 20 years or more, and people keep using it. So we're going to learn it. And so we're going to use it in our notebooks. And actually, would you excuse me a moment? I think I have to go deal with the dog really quick. I'll be right back. Sorry about that. We're getting a bathroom reno done and had to let the guy who's doing the work in the house. So anyway, so yeah, matplotlib is a very popular plotting language, or sorry, plotting library. I don't use it myself too much, but a lot of people in the sciences do use it quite a bit. Now, the one that I like to use is called Plotly. And I usually teach that as an add-on course, but since COVID, we haven't been doing that add-on course. But I have a feeling that probably in the when we do the winter boot camp, we'll add that Plotly course back in. But having said that, matplotlib can do everything pretty much that Plotly can, and Plotly can do pretty much everything that Plotly can do pretty much everything that matplotlib can do. Plotly is really nice for interactive, sort of web-based visualization. So it's has a certain use case that it's good for. So today we'll learn the old standard one, and the nice thing about using a plotting library that's standard is you're going to find lots of code snippets and examples on the web that you can borrow for your own work. So let's get started. So the first thing I'm going to do is I'm going to type something weird into my notebook, and it looks like this. Little %, mat, plot, lib, inline. My VM spinning up, and there we go. So that's called a magic command. Anything that begins with a % in Jupyter Notebooks is called a magic command. You don't have magic commands in straight Python, but in Jupyter you do. And this magic command, what it's doing is it's telling the Jupyter Notebook every time that we create a visualization with matplotlib, embed it right in the notebook rather than spawning up a new window, which is the default behavior of matplotlib. So that's why we're doing this magic command here. And then the next thing we'll want to do is actually import matplotlib. So it's a non-standard built-in libraries, but it's in a module, so we have to import it. And yeah, so this is here we are importing it, and this is a very standard way to import matplotlib as an alias. So people usually use this submodule called pyplot, and they'll import matplotlib.pyplot as PLT. So we're going to use the three symbols or the three letter module alias PLT a lot in what follows. So I'll just mention that it's not a built-in library for Python, and so it's quite possible that if you're on a machine of your own machine, not Google's Colab, you might need to do something like this. Colab comes with a whole bunch of libraries already installed, so I'm gonna pip install it, and pip is gonna tell me, well, you know what, it's already installed, so I'm not gonna do anything. So let's try plotting something. This is pretty simple. So let's create basically some x-axis variables. Oops. Just moved the window around there. So time, I have 4 values for time. And position. Do 0, okay, so there's 4 values for the y-axis, and here it goes. So we do plt.plot. Don't run the cell yet until we get all of this down. Okay. Okay. That looks about right. Give it a run. So what did I do? I put plot. It should be PLT. There we go. There's our first plot. So pretty easy. So PLT is a module, and we essentially do a few things that alter the state of the matplotlib module, and eventually when we run the cell, all those things come together to make the plot. So we tell it what to plot. We say, well, plot time versus position. We give a couple of labels, and then when we run the cell, it works. So what's not going to work is if you had, so I'm just going to copy and paste now. If I grab those first 3 lines, run those, and you notice there's no labels, and then put these in another cell and ran that. So, well, yeah. So the first one is a plot with no labels, and the other one's a no plot with labels. So it's you got to make sure it's all in the same cell. Is what I'm trying to get at, is have all 3 of those lines in the same cell before running it, or you're going to get unpredictable results. Okay, do we have any questions about that? Okay, so we've seen Pandas data frames, and wouldn't it be cool to plot some of those? So why don't we do that? So I'm going to go to my, that Etherpad, or sorry, the Etherpad, and I have some code here again that we can copy and paste. And this is that download function from last time. And we'll grab a few more of those CSV files. So I'll copy, and then paste. And I'm just going to copy and paste also the address to the Etherpad again into the chat in case people missed it, the link. Okay, so this is the same download function as last time. And we're going to download 4 files at the bottom here. So we define our function, and then we run the function to download. Hopefully all the indentation is going to work out. Looks like it worked out. So we got our 4 files, and I'm going to confirm again. Click on the Files tab, look in the data directory, and there's the 4 files that I just downloaded. Great. And so let's try plotting from a Pandas data frame. So don't forget, Pandas isn't built into Python, so we have to import it. And let's load some data. So I'm going to do this is read CSV, same as last time. Name of the file. So load the Oceania one. What is it called? Oh, it's called gapminder underscore GDP underscore Oceania CSV. And again, we'll set those index for the rows to be the country column. Makes everything look nice when you do that. Okay. So let's do a little bit of surgery on the columns. So if you remember, we could do the following: Oceania df columns, and these have these horrible GDP per cap underscore prefixes on all the column names, which is not great. So let's fix that. So what I'm going to do is I'm going to extract the years. So what I want to end up with is I just want 1952, 1957, 1962 to be the column names, and so we'll extract the those years out first. So here's a little bit of magic that you have to trust works. So I'm stripping off the GDP per cap underscore. Sorry, in my notes, the data frame is called data, and I think Oceania DF is a better name. Let's see what that years looks like now. It's an index with 1952, 1957, 1962, etc. So if you can visually see, you might not understand what everything means in this line of code, but there's this method called strip, and we're stripping off that GDP per cap underscore. Okay, so then we can set that back to the columns, and we do a little bit more magic, which actually, so if you look at these years that we stripped off, they're all strings, they're not numbers. Numbers have nice properties when you're plotting, so let's convert them to integers. So we could do years and as type int. And again, I wrote data, but it should be Oceania underscore DF. Okay. Oops. That's interesting. Well, let me just see what happened. Did that actually do anything, or is that? So, user warning, Pandas doesn't allow columns to be created via a new attribute name. Okay, well, that's kind of weird. Never had that happen before. Okay, well, I ran it the second time and it worked. Or did it work? Okay. If I just put years here, is that gonna? Oh, I lost my, this is something that I've never seen before, so maybe it's something new in recent version of Pandas. So go into my old friend Google. I'll do it here, Pandas. Allow columns to be created.
Hello, Chris.
Hi there.
I saw someone said in the chat box that the spelling of column is wrong.
Really? Well,
Yeah.
that would explain it. And that totally fits. 2 M's. There you go. Thank you very much. So let's try that again. Sorry about that. This dot is type int. Okay. Thank you so much for pointing that out, everybody. That's one day I'll learn to spell. It's not going to be today, though. Okay, here's some magic. So Oceania, I can spell right. So if you recall, this is grabbing the row for Australia. And there's a little function called plot that matplotlib adds to the data frame, and we have a graph. So of course, all of this other stuff was just to make these things down here look nice. I mean, if all of those labels had said GDP per cap, GDP per cap, GDP per cap, that would look pretty horrible. So we cleaned up our columns names, and then once that was done, the plotting was actually really basic. So you just pick a row and plot it over the various years, and you can watch the GDP per capita evolution over time for Australia. Now, what if you wanted to, we have 2 countries worth of data in the in this data frame. So look at, there's Australia and New Zealand, and what if you wanted to plot both of them? Well, we might want to try the following. Yeah, move that away from the bottom so it's hopefully the zoom controls aren't covering stuff up. So since it worked for one row, how about for the whole data frame? Let's give it a try. It totally worked, except it gave us something truly horrible. I don't think this is what anybody would have wanted. So it's we have on our x-axis, we have Australia at one side and New Zealand at the other. Y-axis looks okay, but then it's given us a separate line for each year. And so it's almost as if, the rows and the columns are swapped around from what we want. And I don't know, can anyone think of a way if we wanted to swap the rows and columns to make this right? What would you do? Well, yesterday we saw the transpose of a data frame was dot big T. Why don't we try plotting that instead? Maybe it'll do something sensible. Yeah, there you go. So in this case, the data matplotlib got a bit confused between what needed to be, which data needed to be a separate line in the graph. And so flipping the data set around made it good again. So now we have one line for Australia and another line for New Zealand. And it's kind of cool that it's all basically a one-liner to plot that stuff. So are there any questions people might have? And if we wanted to, you notice there's no labels on here, but we could definitely go Oceania df t.plot, and then I'm not going to run this. On the next line, I'll do the same thing as before, plt.ylabel. Set that to GDP per capita. And you run that, and at the very least, we get a Y label. We can do the same with the X label too. Okay, so we have these two line graphs, or two line plots on the same plot. And what if we wanted a bar chart? And what if we wanted to change the styling of our graph too? Well, there's a submodule in matplotlib called style, and you can tell it to use a style. People coming from R might be familiar with ggplot. So there's a ggplot. So GG, I think, stands for Grammar of Graphics, which is the sort of plotting paradigm that R uses, and it's the name of the plotting library. Yeah, so for matplotlib, they've implemented something to make the graphs look like the ones that come from R. And we can do Oceania df, and don't forget to do the .t plot. And this time we're going to add an argument to the plot function, and this is a keyword argument. So the kind of plot we want to do is now a bar chart. Oops, bar. And we can add the label again on the y-axis. Give that a run, and that's what you get out of it. So that ggplot adds these gray colored grid lines in the background and handles some of the default colors. You might be thinking, okay, well, what other kind of styles are there? Well, I would, if I were asking that, I would, go to the I'd look here. So help on plt.style. And that doesn't tell me too much. So I'd go one level deeper. So there's a use function. So I'd say, okay, help plt.style.use. So the documentation for that function says style settings. There's a style name called default. So if we wanted to convert back to the original style, we would use default. And here's that first argument. So is a string. So let's see, use style. Style is a string, has a string, dictionary, path, or list. And the string is the name of a style. And if we want to see the available style names, we can use style. We can look at style.available. So let's do that. Help for PLT. Geez, forgot what my module is called. Style.available. Let's see what it says here. Okay, so it's a list. So help may not be what I needed. Instead, we'll just do, and here we go. Here's a whole bunch of styles that we can look at. So we see BMH, classic, dark background, and so on. Here's that ggplot. We could try, that sounds interesting, Seaborn dark. Let's try plt.style.use Seaborn dash dark. And I'll just plt dot, or sorry, Oceania df. Don't forget to transpose. Plot. I could do bar graph again. Kind equals bar. Let's see what we look at, what it looks like this time. Well, that wasn't exciting as exciting as I'd hoped it'd be. But anyways, you can poke around at these styles, and there may be some that have some nice visual appeal to them that you can play around with. So yeah, the first time we ran that plot function, we had a couple of lists. So way back up here, we had a time list, a position list, and we called plt.plot. And we can do the same thing for a data frame if we want to. This time I'm going to use the plot function because it has some nice features for some further styling. And so what I'll do is I'll strip out the years. So there's the x-axis. Here's my y-axis. And so now I'll run plt.plot like in the first example on these two. Now this is essentially a list. This is a series, Pandas series, which is essentially a list. So we're plotting two lists. So I can do plot first thing versus second thing. And now I'm going to add a third argument here. And it looks like this. And let me know if you know what this thing is doing. Oh, I wrote, did I spell Australia wrong? I forgot the word loc, I think. Yeah, it's okay. I guess I haven't had enough coffee today. So plot out the x values, or strip out the x values, strip out the y values, plot them, and then we have this third argument. And can anyone tell me what that's doing? Okay, well, the probably no, yeah, it's the marker type. So the G in this case stands for the green color, and then the two dashes mean is a shorthand for dashed lines. I'm not a huge fan of this syntax because it seems like it doesn't scale very well. But on the other hand, it's really quick to type, so it does have that advantage. So maybe we'd be wondering, what are all the different kind of things we can put in this third argument? And again, time to go look at that help function. So this time we're looking at the help for plt.plot. And so there's lots of documentation. So the actual function has variable length arguments. It's hard to read what this help does without getting deep, but then they show some examples. So plotting x versus y, adding blue circle markers with this BO, red plus signs, and when you get closer to the bottom of the documentation, you can see that there's all sorts of different little shorthand characters you can throw in there. Let's try years. Let's try that BO one from the documentation. BO. What did I do? Oh yeah, that should be Australia GDP. I just can't spell today. GDP underscore Australia. I got the order wrong. Why? All right, there we go. Is it going to do it? It did it. So there we go. There's the blue, the round markers that are blue, and that's represented by the B and the O. Yeah, the help function is your friend for figuring out what all these different options will be. Okay, and we can similarly we can strip out the New Zealand data. And we can plot in the same graph just by calling the plot function more than once. So let's try the following. We'll plot or plt.plot GDP, oops, years versus GDP. This time we'll make it a blue line with this will give solid markers. Now the plot function also has some keyword arguments, so we can give this particular line a label in the legend. And we'll say, okay, the label is Australia. And if we run plt.plot again, this time plotting years and GDP New Zealand. This time we'll give it a green dashed line and label equals New Zealand. We'll do some more fancy stuff. So we'll explicitly tell it to give the legend. I mean, it was giving a legend anyways on some of these multi-year plots. But this time we're going to give it an argument saying where we want it. And we can say, okay, I want it in the upper left of the graph. Give it an X label. Year. Give it a Y label. GDP capita. I think there might be an option for title. It's not in this example, but say probably gonna get bit on this one. Let's do it anyways. So yeah, there we go. Make this a little bit bigger so that the code shows up with the graph. So yeah, so the first plot is plotting the blue line for Australia. The second plot command is creating this dashed green line for New Zealand. We put our legend in the upper left. Upper right wouldn't be so good. It'd be covering up some of the line. Yeah, I suspect if you don't put in a location, it tries to do the best it can to not cover stuff up. But that would be worth a trip into the documentation to find out for sure. Our X label is year. Our Y label is GDP per capita. And then we added a title here, GDP per capita for Oceania. You might be curious about how the growth in GDP in Australia relates to the growth of GDP in New Zealand. And a common way to visualize that is through a scatter plot. And we can certainly do that in matplotlib. So we can say, okay, plt.scatter, and we'll plot one of them versus the other. Australia. And here you go. So the years have disappeared from the graph. So each dot represents a different year. And you can see that they're actually pretty highly correlated. So not too much of a surprise here. There's some cute. And another way to do this is through the data frame directly. So the pandas data frame. So I could go Oceana_df. Of course, I have to transpose it. Plot. And it's really weird syntax. We're going to add after plot the word scatter. And we can say x equals Australia, y equals New Zealand. And yeah, so in this case, I didn't have to use these stripped out rows, but I used the data frame itself. And as a bonus, I got some nice labels for the graph too. Lots of options with matplotlib to do lots of different things. A lot of it's just playing around. Okay. So here's an exercise, and I'm going to get you to do. So it's a fill in the blank type thing. So what we want to do is we want to have two lines on a plot, minimum and maximum GDP per cap for Europe. And so here's the code skeleton. So I'm going to leave this as blanks. Blank here. Here's an option we haven't seen yet. Location equals best. So it's we're letting matplotlib decide where to put the legend. And here's another option we haven't seen before. And we'll see why, I think, once we fill in the blanks and run the graph. So I'm gonna give that 5 minutes to give that a try. So the goal is to have one plot that has both the minimum GDP lines and the maximum GDP lines. And we'll give it a go. So any questions while we're going into this? I'm just going to set up the timer. Actually, when you're done, if you can put up a green yes in the participants panel. Oh, hey, Ira James. If you check out the Etherpad, there is the so the link above that Camille just posted. There's some code that you can copy and paste that will download the data files. Okay, any other questions? Okay, I'll let it go for a bit. But if you have a question, feel free to unmute or to type something into the chat. Okay, five minutes goes by quick. All right, so first thing we want to do is, of course, fill in the data file that we want to load. So yeah, it's Gapminder. You're up. .csv. And as usual, we want to set the index column to be the countries. Country. Okay, so then we saw, last time we saw there was a bunch of aggregate functions you can run on data frames. The one that we're interested here is the min function or min method. And similarly for the other line, we're going to want something very similar, but with the max method run. And we can label that one max. Looks like everything is set up to go. And yeah, so now you see what happens when you don't strip out those years out of your columns. So it's super long. So if you're wondering what this x ticks rotation equals 90, well, imagine if we didn't have that. So I'm just going to copy and paste everything except for that rotation thing. So I'll just get rid of that line altogether. And this is what you get. You get all these strings in the x-axis blending into each other. So that's why we did that rotation equals 90. Okay, any questions? Okay, so let's load another file. This time we'll do Asia. Okay, and let's plot the let's take a look at the following. So we'll do Asia dot describe. So we'll do the descriptive stats. T. This is getting a little crazy here. Oops. Kind. scatter x equals. So we're going to do a scatter plot with that's going to compare the min and the max values for each country, or for each year, I mean. So what's going on there? So let's, why don't we just pull out, remind yourself what the describe does. So that's, so that should be underscore df. So we got these descriptive statistics, and this in fact is a data frame also. So if I do type Asia df.describe, we see that it returns a Panda data frame. So it's tabular data. So it's here's the rows, here's the column. So we're doing a scatter plot. Well, we're doing a transpose because that's what it wants. And yeah, oops. So I'll put the dot .t here. Oops, that was the type one. I'll put it here. Dot .t. So we're taking out the min here and the max here, and we're doing the scatter plot. And you can see that there's the correlation between the minimum and the maximum of any given country for GDP, or for the minimum and maximum of each year is not quite is not at all correlated. It doesn't even look like an inverse correlation. It just looks like a mess. Actually, this looks like a trend maybe going this way, but these two are definitely outliers from that trend. So yeah, then the I think the note is that the variability of the maximum is a lot higher than the variability of the minimum GDP per cap. Okay. So we're plotting in a notebook. We have these plots that live in the notebook, but they don't live outside of the notebook. So at some point, you'll probably want to maybe save a plot. There's a function in matplotlib called plt.savefig. Let's see what it does. So I'm going to call this my figure.png. Give it a run. So right here, I'm wondering, okay, all those plot commands had to be in the same cell. So I'm wondering if this save fig has to be in the same cell as the plotting command. So let's give it a run. So it saved 432 by 288 figure. And it says it was 0 axes. That sounds bad. So let's take a look at what it did. So here it is in our files, and double click on it. It looks like an empty graph. Let's try that again. This time we'll actually do some plotting. We can do let's see, Oceania df dot plot kind equals bar. Make sure it runs first. Oh, that didn't do it. I forgot the dot t. That looks a bit more reasonable. Okay, so in the same cell, I'm going to do that plt.save fig, and I'll call it my figure 2.png. I'll take a look in the files. Actually, let's okay. Well, and there we go. It's saved to the PNG file with the plot. If you want to download it, you can do so from here. One issue with this plot, let me see if I can do this. Can I zoom in? I'm gonna get in, zoom in real close, and you'll notice that the letters are getting fuzzy, and it's when I zoom in, it's because this is a it's what's called a raster graphic. So PNG encodes pixels. It doesn't do a vector graphic, which of course is not going to make our plots publication friendly. But the good news is that there's you can save in other formats too. So let's try the same thing. So Oceania df plot. I won't even do a bar chart this time. And this time I'm going to do plt.savefig. And I'll call this my figure. This time I'll do SVG. So I don't know if you're familiar with it, but SVG stands for Scalable Vector Graphic. And it's a file format that is works pretty good for publication, and it's infinitely scalable because everything's encoded as vectors rather than as pixels. I'll take a look at the file that was generated. Here it is here. It offers to download it, so I'll save it in my temp directory. And so it doesn't know how to view a SVG. I call it my figure. So just in my browser, I'm doing this. myfigure.svg. So I've downloaded it to my own computer. And this is what I get. So now I can zoom in. It doesn't matter how big I zoom in. I've got nice, crisp graphic elements in my graph. Lines are nice. There's no jaggies on the line or any blurring. And we've essentially have something that we can send to a publisher potentially. Okay, any questions about figures? There's a number of settings. You know, if you want to make your plots accessible and easy to read. So there's We've seen X label and Y label and title, which give you the viewer of your plot some information to make sense of what you're showing them. There's other parameters like font size where you can make larger fonts if you need to. We've seen the legend one where we can move our legend around, and yeah, there's lots of different options to play with. What I usually do, my workflow is I'll play around with the plot for a bit, and I won't get what I want, so then I'll go to Google and I'll try and Google for the thing that I'm trying to do, and chances are I'm not the first person to have so someone else on the internet has solved the problem that I'm trying to solve previously, and I can find that on Google. Usually, quite often there's links to a website called Stack Overflow that helps with a lot of programming problems. So yeah, if you need help with Matplotlib or plotting in general, or with Python in general, Stack Overflow and Google are good resources to look for solutions. And that's basically all I've got to say about Matplotlib for now. What questions do people have about Matplotlib or about anything else we've talked about today or other days? So yeah, I'll move on then. But first, just to summarize, so Matplotlib is the most widely used scientific plotting package in Python, um, and it's nice that we can plot data directly from a pandas data frame. Um, and we can do some stuff with our data frame. So for example, we could plot those descriptive statistics in interesting ways. And so it's the fact that it supports data frames is really nice. We saw a whole bunch of styles. Yeah, you can plot a lot of data sets together, and you can export to figures and do lots of good stuff. Okay, so it's 10:14 right now. So why don't we take a break before I move on, since it's a nice logical spot to take a break. Next thing I'm going to be looking at is looping over data sets. And so it's 10:14 right now. Why don't we come back at 10:30? And in the meantime, if you have any questions, feel free to unmute or say them in the chat. I'll stick around here for a couple of minutes and I'll take a short break myself. So we'll see you in a bit. Hey everyone. I hope you had enough time to relax for a bit. So we're done with plotting. And so let's look at looping over data sets. So we're going to have to grab a whole bunch of files in order to do this. So what I'll do is I'm going to copy and paste what we need into the Etherpad. Go to my course materials, looping over data sets. This is essentially what I'm going to copy and paste. So I'll put that in the Etherpad first, and then I'll so we don't have to redefine the download function. We already have it. And there's the snippet of code to download 1, 2, 3, 4, 5, 6 data files. Okay, so I'm going to copy and paste this code into my notebook and give it a run. Oops, that's not good. Did I get one of the names wrong? Okay. Can experiment with to find out which file was named wrong. Right. Okay, just out of curiosity, can people hear me? I have a report from my coworker that he can't hear me. If
I can hear you just fine, Chris.
Okay. So Camille, you got to fix your headset. Okay, so I don't know what happened here. All the way to the. So this seemed to work earlier in the day. Copy and paste it and try it again. Did I have a spelling? You know what probably happened is some issue with copy and pasting. I might have gotten some special characters in here somehow. It's a little bit weird. So how different does that look? I'm going to copy and paste my previous stuff and then put in the missing ones by hand. So I'm missing. I don't know if you guys get the same error that I do. So, oops. Add Africa. SV. Add Americas. Plus side, I don't have to worry about the GDP of Antarctica. Oh, I think I see the problem. Yeah, okay. This is a problem. I didn't have a comma at the end of this line, and it was treating this and this as one long string. So let me fix that in the Etherpad. So right here is the error. That should be a comma there. So if John and Camille can make a note that I have a typo to fix, I'll try and look at that when we're done for the day. So, all right. So yeah, if you have the so let's look in. So I'm going to write ls data, and I see there's 6 files there. If anyone doesn't have all 6 files, let me know and we'll see if we can help you out. Okay. So let's do a little loop. So what we'll do is we'll loop over a few of the files and we'll load them up and we'll print the minimum values for each year for a couple of countries. So let's look at what that might look like. So we start with a for loop. We need a loop variable. So file name is probably a good variable name. And so one of the files we might loop over could be Africa.csv. Second one in our list, so I'm creating a list here. Data / GDP underscore. Move my window up a little bit so it's hopefully the zoom controls don't cover what I'm typing. Oops, gapminder underscore GDP underscore Asia CSV. And since it's a loop, we got to end the line with a colon, and then we add the loop block. So what I'll do is I'll do so data frame. A bit of redundancy there, but that's okay. So read the current file of the loop into this variable called data.df. And again, we strip out that index column. Now we can do a print statement. So we'll print the file name. So you gotta remember, file name is comes from this list, and it's one of these two strings. So it's a string. We'll print it. We'll print the file name, and then we'll print the value of the data frame minimums. Cool. And when I run that, so here's the code that I'm running, and so it prints. This is kind of bad, the formatting, but it prints the file name, gives us a space, and so it didn't do a new line, but it did a space, and then started printing the minimum values for each year in the data set. And so that's for file number 1, which is the Africa. So file name for the first time through is the Africa file name, and then for the second time through, file name is the Asia file name. So read in that file. So here's the file name again here, and then it prints those minimum values. I don't like that formatting, so one thing we could do is add a, if you remember the special characters with the backslash, well, this one means a new line. Still a bit of a problem. It puts in a space here, but at least the file name's on a different line. I guess if I didn't like that space, I could have added another plus sign here. Because if you remember, the print function puts a space between each of its arguments as it prints out. And, oh, that didn't work. Well, I didn't like that I'm adding a string with something that's not a string. So why don't we convert this to a string? See what happens. Is it going to work? That works. So that's a little bit nicely formatted. I can add another line, new line at the end. That looks even better. So we have a file name, bunch of data, a blank line, then the next file name, bunch of data. So yeah, you can sort of wrangle around with the string formatting to make the printed output look a bit better. So the whole point of this is that we're doing a loop over some file names, and then we're loading in a file. We're doing stuff with the file. Then we go to the next file and loop over it. Now this is a bit of a drag, writing data / gapminder gdp africa.csv data _ gapminder, or data / gapminder _ gdp _ asia.csv. And if we went through all 6, this would get to be extremely tedious. Luckily, there's something called globbing. So globbing means, it's kind of weird word, but it means matching a set of files with a pattern. So people from Windows might occasionally see something like star.star, where it means, okay, match any file that has a dot in it. So, or if you're from Unix, you might have like, okay, let's get all the files that match the pattern star, or, well, let's do something a bit more concrete. Star.csv. So that'd grab all the CSV files in a directory, and if we want to be more specific, this would match all of the CSV files that we've downloaded. So that's essentially globbing. I don't. If there's someone who hasn't done globbing before and needs further explanation, let me know, and we can talk about it a bit further. But essentially, that star right here means match one or more characters in the string. So certainly, and this is in the file system in the directory. So you know, we go into the data directory, and then we match and a bunch of unspecified characters, as long as there's a .csv on the end, and that will certainly match everything in the data directory. And I can even run this, and it'll show me the 6 files. If I change this to, here's a pattern that matches all the files that have 2 underscores in them. So match ambiguous or arbitrary number of characters, then it has to have an underscore, match a bunch of other characters, then it has to have an underscore. And I'll put one more star here. And what does that return? So that returns 5 of the files. The one that it doesn't return is the .all one, or underscore all one. So there, this is the one that doesn't match because it doesn't have 2 underscores in it. And that's how you glob files. And Python thankfully has a library that, so this is an operating system function. It's not really Python when I do ls. So let's see how we would do this in Python. So turns out the function you want to use is called glob, which is kind of a terrible name. But first thing we do is we import a module called glob. And now we can do something like this: print all CSV files in data directory. Colon, comma. Now I do my glob.glob, glob. And I put in my globbing pattern. So there's data slash star.csv, just like I did with ls above. And this is what the output is. So all CSV files in data directory. And you notice it's printing a list. And that's good for us because we know how to loop over lists. So the square brackets is the clue that it's a list. And it gives us a list with 6 items in it. Okay. I didn't mention this, but there's another globbing pattern called question mark, which matches only a single character. I don't really see a good opportunity to exploit that pattern in our data. Yeah. So if you need that one, it's what looks like. So if you had a pattern like this, .txt, the pattern looked like that, and it would match files that look like bird.txt and bard.txt. So that's this is a yes. This is a yes. The following, however, is a no. Beard.txt. So the reason why it doesn't match is that this question mark character only matches a single character, not unlike the star, which if this was a star, it would match all 3. But since if you use a question mark, it's only going to match that single character as a wild card. Yeah, and these stars are often called wild cards, and same with the question mark. Okay. All right, so now we've learned about globs, so let's give it a try. Or glob. So for file name in glob.glob data slash gap reminder star.csv. I think that matches all the files, so I didn't even need that gap binder in there underscore. But I think it's good to be as specific as you can be. So load our data frame. File name. And we can print file name. Don't get too fancy with the formatting. Notice I didn't include the index column either because this is just a quick example. So get the minimum for GDP per cap underscore 1952, and yeah, take the minimum. Oops, I forgot the underscore CSV. There we go. So in 1952 for Oceania, the minimum GDP was 10,000-ish. For all the data sets, the minimum value is around 300. That value seems to come from Africa. Asia also has a low minimum. Americas has some low numbers, and Europe has some low numbers too, but Well, there's only 2 countries in Oceania, and they're both fairly wealthy, so that's that explains why that minimum value is really high for Oceania. And we have that information thanks to looping. I mean, this is a lot nicer than having to write out each file in as a list. Okay. Here's an exercise with globbing. So what we want to do is we want to find well, maybe I'll just walk through this one. So this will be the file with fewest records. So fewest number of rows. So I'll do the start it off with fill in the blanks, and then I'll walk through it because I don't think I've covered everything, so I'm a little concerned. Glob.glob data / star.csv. Don't forget the colon. And data df equals read pd.read csv file name. So here's the part that that we may not have seen before. So I didn't talk about the shape function. So let's maybe before I run the fill in the blanks, we'll take a look at that really quick. So unindent, and then at the very end we can type smallest file has, comma, fewest. I'm sorry, I went to comma, I put a period. Records. Okay. So I'm not going to run that quite yet because it's not filled in. And so let's look at Oceania DF. So that has 2 records, and I think it was 12 years. So there's a function called shape. And gives us the shape. So, oops. Sorry, that's not even a method. It's like a state variable, so you don't need braces. So the first entry is a 2. It's kind of like a list. This is called a tuple. They use round brackets rather than square ones, and their tuples and lists are for the most part interchangeable. So 2 is the number of rows, 12 is another number of columns. If I wanted the number of rows, I could do shape 0. So that's the first item in the tuple. If I wanted the number of columns, I could do shape 1. Now, a few other ways to get this information. I think the len function works on data frames. Let's find out. So that tells me 2. So I could run len to count the rows. I could also do len on on the columns indices that we remember when we were manipulating those column names to turn them into years. Well, this is the thing that we're working on. And yeah, so that should be columns. You have days where you just can't type. I do. So you can get that information in a number of ways. So there's this shape attribute of the data frame. So it's a tuple, or you can take a len, or you can take the length of the columns. Okay, so back to our little code snippet. This is basically that accumulator pattern again. So we'll start with a variable that's initialized. So, and then we will overwrite it. So now we want a really high value for, so what we're going to do is we're going to loop over the sets where we want this to hold our fewest number of rows in a data set. And then when we see something smaller, we want to overwrite that value. So we have to initialize it to something really high. So we could pick a really big number. Let's do that for the first pass. So currently we say the fewest is, I don't even know what number that is. It's either billions or trillions of dollars of GDP, which clearly none of our data values have. And we can say, okay, as we loop through the data set, we'll load in the file. And if the new data set that was loaded has a number of rows that is less than the fewest, so the minimum of those two numbers, then let's overwrite that value. Otherwise, if this thing currently set to, or sorry, if this fewest value, which is currently set to 1 billion or 100 billion or whatever that is, if that's lower, which it won't be, then we'll just keep our old value. So we'll give that a run. Sorry, I put an equal sign there. It should be an in. So the smallest file has 2 records, and sure, that's the Oceania one. Doing maximum is easier because we could have set this to 0 and set this to max. We can rewrite our code and it tells us the small, or well, should change the string to say largest. So the largest file has 142 records. But I'll set that back right now. So here's another way to specify a really a really large value is you use this. So fewest equals float infinity. So we'll set the initial value to essentially infinity. So the representation of infinity is that when you compare any numbers with it, they're always less than it. So let's just take a look at this. So float inf, what does that look like? It just says inf. So what if I say really big number? Is that less than float inf? That's always true. And if we switch the inequalities, it's always false. So and it doesn't matter how many zeros we add. We always get true for less than. So it's essentially a representation of a number that is larger than any other number. And you notice that we're using float here, so we could use a floating point number here. Okay. So we fewest equals float inf to start with. We loop through the file, we get the number of rows, we compare it with the fewest and overwrite our value of fewest when we find a number that's lower. And then at the end we have the value of the. Of course, we don't know which file it is. And if we wanted to do that, we'd have to update our program a little bit. So we could do min file name, start with something empty, and then we have to work through a loop. So we'll look at conditionals a little later today, but our code would sort of change like this. So if data df dot, I'm going to use len this time because I can. So if that length is less than fewest, probably should have created a new cell for this. Then we can say, okay, fewest equals len data df, and also min file name is equal to the file name index here at our loop variable. And I can just get rid of this line here. And I can rewrite my output to smallest file is file name, comma, and it has. So we get a little bit, making our program a little bit more complex, we can get some more information. So smallest file name is data gap miner GDP. Hold on a sec, that doesn't look right. Europe? Did I get my? What did I do there? Anyone see the mistake? Why? I mean, there's no way Europe has the least number of lines. Should be Oceania. Here's the problem. It's not a problem with the algorithm, it's a problem with the output. So turns out that Europe was the last thing I iterated with, so that file name variable had Europe. Yeah, thank you very much, Matza. And so, yeah, thanks. So that's a min file name is what we need in the output. There we go. So that's a little bit of a update to make our program a little bit more useful. Okay. Questions? Do you have any questions about this? All right, so that's about all I have to say about globbing and looping over files. So we use a for loop to go through all of the files. Using that glob.glob method really made it easy to set up our input for our input collection for our loop. Rather than listing the files by hand, we used some nice file matching patterns. And yeah, we could loop over some files and get some information about them. Okay. So we're going to talk a little bit more about writing our own functions. Okay, so we've seen some functions already, and we've written one of our own. So at the very top of our notebook, we have our download function. And so what were the properties of our download function? Well, we had this word def. So we're defining a function. We give the function a name, and we list 0 or more arguments. So in this case, we have one argument called file name. And then just like the looping, well, we have the colon at the end of the line, which tells us a block is coming up. And in Python, we indent our block and make sure everything's indented consistently, and then it works when we run that code. So it defines a function but doesn't run it, and then later on we can run our function on actual data. So writing code in functions solves a number of problems. So one thing it helps to do is it helps reduce complexity. So it's a lot nicer to type download data than to repeat all those lines of code that were in the function definition every time. And we're grouping our lines of code together we're organizing our code into this sort of bundle of code that does a single purpose. So our function downloads data, that's its single purpose. And it's kind of nice to organize your code that way to reduce complexity. We're encapsulating all these lines of code and treating it as a single thing. And the nice thing is that we can reuse our function definition. So we've reused the download data function a number of times. We've put it into loops, and that's really handy. So yeah, and it's so the like I mentioned, you need the keyword def. You need a function name. You need arguments 0 or more. So this time I'll put in 0. You need that colon, and then you can add a block, 1 or more lines of code. I run it, and does it print anything? It absolutely does not print anything, because all I've done is defined a function. I haven't actually run it. So once you define it, you can start running your function, and you can run it again. And you can run it as many times as you want once it's defined. Same warning from before. Let's say you're writing your code and you think, hey, I know a great variable name. Let's call it print greeting and set it equals to 5. Can I run the print greeting function anymore? No. Python gets mad because it says int object is not callable. So I've completely destroyed my definition of print greeting. We saw this with the min function and the len function. And the way we solved that for the built-in functions was we did the following: print greeting. And in those circumstances, it would restore the previous value. But since this is a function we wrote ourselves, no dice. So once we deleted the definition from our namespace, print greeting is no longer known. So it's not the same as doing len equals 5, del len, and then I can do len horses, and it'll give me the right value. So I overwrote the len function. I deleted that. So len is a built-in function. When I did del, it restored the previous definition of what len was so that I could run len on horses again. It doesn't work with functions we write. The only way we're going to get that function back again is coming up here, either copy and pasting the code or rerunning the cell again. So you notice I have 106, 99, 100, so my cells are out of order now, but now I can run my function again and it'll work. And then I'll just make sure that I never run this again where I overwrote my definition. And Python doesn't get mad at you when you redefine a function with def, so I can run this again, I can run it again. Python doesn't care, it still works. So you can redefine anything in Python pretty much. So let's look at a function with some arguments or parameters, whatever you want to call them. So the function we'll write called print date. And we'll give a year, give a month, and we'll give a day. And we can create a temporary variable, string year, plus put in a slash, plus convert string to a month, plus slash, plus string conversion of day. Okay, so we have this intermediate string, and then we can print it. And of course, since we're only defining a function, the thing doesn't actually run because we haven't given it any arguments. So we can now do print day 2020 10. I should just do 8. Sorry, that should be print date, not print day. And there we go. You notice that it's not so great with the last thing here. Now, if I did put a 08, I don't think that's going to work. What's it going to do? Got angry because yeah, you don't really put zeros in front of numbers. So notice I didn't mention what type of arguments is going on. So I could have put a string here. So the other two are integers. This is a string. That'll work. Looks pretty horrible though. But anyways, the point is that the first argument maps to this year variable, second argument to this month variable, and the third argument maps onto this day variable. And so if you get it out of order, so if I did 10, 2020, 08. Oh, shoot, I put that 0 in. I can't help myself when I'm doing dates. I got to put 0 in front of the single digit numbers. So that gives us something that doesn't look like a very good date at all for a number of reasons. Now you actually can put the arguments out of order and get the right answer by doing the following. Print date. So I could do month equals 10, year equals 2020, day equals 8. So now we've given an explicit mapping between which argument maps onto which parameter, and that gives us the date that we expect, despite the fact that the arguments are in a different order. So the you might say, okay, well that's kind of cool. I want to use a date in a calculation, so I'll do date equals print date month equals 10, year 20 8. Give that a run. Cool. And then I want to print date later, and it says none. So one thing that's missing from our function is a return value. It did return something. It returned something called none, but we want to explicitly maybe create a new function that creates dates so that we can print them later. Our print function just has the print statement. That's pretty much all that it's doing. It doesn't actually return anything. You might be curious, hey, what about that joined variable? Can I look at that now and run it? So Python doesn't know about this joined variable once the function leaves. So this is called a variable scope, and we have a section coming up on that. But I'm probably going to tell you everything you need to know about scope right now. And that's once you have a function and you define a variable in a function, it lives for the duration of the function. And then once the function definition is done, that variable doesn't exist anymore and you can't access it. So beware of that. Okay, so let's create a new function. I'm going to call it format date. And I'm going to say, okay, year, month, day, and we'll create our join. We'll use our joined local variable. That's what these variables that are just defined inside a function are called. They're called local variables rather than global variables. And so we'll set it to the same thing as before. I'm going to use some fancy syntax this time. Watch this. We're going to use a function called format. So here's our slashes, and these curly braces mean chuck something in here. And at the end of the string, we can write .format, and we throw in the thing that we want to throw in there. It's a bit nicer than all this string addition up here that we're doing, and that's kind of horrible. In this version, we have this sort of cookie cutter template of how we want this to look like. Another nice thing about the format function is it'll notice that this is an integer, and it'll convert it to a string, so I don't have to put in this str stuff either. So that's pretty cool. So the last thing we'll do is we'll do return joined. So the return is the keyword followed by the thing you want to return. So I want to return the value of this formatted string. give that a run, and we'll try it out. So format, date, 2020. I'm gonna try. I wonder if I can mix the two different syntax types, or if Python will get mad. If I were Python, I'd get mad at me for doing this, but I'm not Python. Let's see what Python actually does. Well, it liked it, so there you go. So that, and rather than printing a string, that returned a string. And now if we want, we can rewrite our print date function. And it simply becomes, we can use our new function that we wrote, year, month, comma, day. So the input to print date, year, becomes the input for format date, year, and so on. Let's run the new definition of the function that we overwrote. Right. I think there's ways to fix the formatting using that format function. So I might get this completely wrong here. I shouldn't probably go down this rabbit hole, but would this do it? Will Python get mad at me? Yeah, no, I would need, if I looked at Python format, this is called zero padding. So how to pad zeros to a string. Okay. Colon 02 might work. So I'll get rid of that percent. I'll put 02. It's gonna work. Yes. So if you wanted something that was a bit more robust, you might want to do the month and the day with that zero padding. So when there isn't enough, so it says, okay, make the format fill 2 characters, and if there aren't enough to fill it, pad it with a 0 on the front side. Neat. Any questions? Okay, and you're noticing that I have this return function that is that's at the end of the function. Let's say we were concerned with let's look at our format date function again. So let's just do print date. It's a lot simpler. So we'll redefine print date, year, month, day. Let's say we want to provide some consistency to the arguments that are passed. So, for example, the year, we might want to say, okay, well, the length of that has to be 4. So what if we return less than 4? We can return early with something like this, or we could just say return. And then we can do print format date, year, month, day. So I'm a bit of a dinosaur. I remember before the year 2000, and all the years were 2 letters. And so maybe we want to disqualify, or sorry, the 2 number years that people used to use in the 1900s. So this thing will work, 2020, 10, 08, or 8. Oops. Here's something that I should do. Convert it to a string first, and then do it. So it didn't like that I tried to do length on a integer. So here's the new definition, and I run it. Oh, I forgot. Year, month, day. I'm doing crazy stuff today. You know why? Because this is recorded. If this wasn't recorded, I'd do all of this stuff perfectly, first time, beautifully. But now there's a record of me making lots of mistakes. So here we go. So our print function now likes the 2020, 10, 8. But what if I tried, okay, good old 1979, 10, 31, Halloween of 1979. What? Why didn't that do what I thought? Anyone see the mistake I made? Oh, that's weird too. Look at this. Ah. It didn't put the slashes in, and it returned 79, 10, 31. What if I replace this with none? Will that do what I expect? Ah, you know, I did say I was crazy, right? So I wrote print instead of print date. Man, what's going on? So now it prints nothing if I put in 79. But if I change it to the year 2079, it works fine. So the point I'm trying to make here is that you can return from a function early if you want to by putting return at any time. And we can add a return at the end. Here's your date. So here's a function with 2 return values. So return when a condition happens, or return at the very end. And when I run it, it prints the date and then returns the value. Here's your date. If I run it with the other input, that doesn't work. It doesn't print anything, and it returns none. Okay, so that's function definitions. Let's try writing a function. So here is, I want to write a function to, yeah, thanks, John. We'll see you later. So I want to write a function that takes a data frame, file name, and then prints the minimum. So I'm going to do this as a fill in the blank thing. So let's write a function called min in data. And it's going to take an argument. I'll leave that blank for a second. Use that colon, and then we'll start doing the I'll call this data df equals bunch of blank stuff, and finally return bunch of blank stuff. So I'm going to give you 3 minutes to poke around at that and see if you can fill in those blanks, and then I'll walk through it. So I know it's 3 minutes isn't a lot of time, but we're only have about 28 minutes left in the course, so we'll see how far we get. So try and fill in the blanks here. So what are we doing? Function takes a file name for CSV, returns the minimum value. Okay, so I'll start working through this. So we know it takes this function takes in a file name. So a good name for our argument is file name. And we've done this a number of times already today, which is pd.read CSV file name. And then what's the return value? Well, you take your data frame and you return the value from min. There's our function definition. We'll test it out by running it on a file name. So let's try data / capminder GDP _ Europe .csv, and it returned the value that we expected. We can combine that with what we learned in the last section. So we could do for file name glob data slash star csv and data file name. So once you have your chunk of code wrapped up in a function, it makes this sort of operation look really clean and it worked, but what I forgot to do is actually print stuff. So print file name and then data file name. And there we have some actual output this time. Printing the file name each time. And then we run this function that takes the file name, loads the file, returns some in value, and printing that too. Okay. Okay, let's, why don't we end this section now? I'm sure we'll see more properties of functions in the next section too, or next following sections. So the key points are that we are encapsulating data. So what does that mean? We're taking a bunch of data, a bunch of lines of code, wrapping them into one little package. So we're breaking down our code into functions to make them easier to understand. So how do we define a function? We use that def keyword. We provide a name for a function. We provide 0 or more parameters, a colon at the end of that line, and then we provide a block of code that works on parameters. Defining a function doesn't run it. So the arguments in the call are matched to the parameters in the definition. And typically that's in order, but we can use those keyword arguments too. And pardon me, functions can return a result to their caller using the return keyword, which can be used anywhere in a function. So and we'll move on to scope. And I don't think I have a lot to say about scope that I haven't said already. Let's look at the following. Pressure equals 3.9. Just T. Temperature. T times 1.43 divided by pressure. Turn temperature. There we go. Just define a function called adjust, and it's adjusting a temperature value to take into account pressure. So we have some variables defined. We see there's one called pressure, and one called T, and one called temperature. As we saw in the last section, temperature is what's called a local variable. It only exists inside this function. Pressure is defined outside of the function. It's called a global variable. So the function can use this value of pressure to for its execution. We can certainly do adjust 0.9, and that gives us an adjustment of 0.012 whatever. And one thing that's a little sneaky, so I can run that again. 0.9, and I get the same value. But since we have this global variable that affects what this function does, we can actually rewrite it here, 150. And now when we run the same function with the same arguments, we get a different answer. Well, I have to spell it right too. So that's kind of a problem with global variables is you can get some unexpected results, because if you expected adjust with the same arguments to return the same value all the time, you can't guarantee that anymore, because your calculation in your function depends on something from the outside of the function. So watch out. I probably, if I was 100% sure this would never change, this pressure conversion value, I would probably put it in here. So maybe I'll just write pressure 2 T. And so I would have done pressure equals 109, 3.9, and temperature equals T times 1.43 divided by pressure, return temperature. Now this only makes sense if we're 100% guaranteed that the pressure never changes. What if it does change? Well, I think a better way to make this function work is to add pressure as a argument instead. So pressure 3 T comma, oops, sorry, this should be called adjust. Getting my names wrong here. Adjust. This is adjust 3. And then we can have pressure as an argument. And I'll just copy and paste to make this a little quicker. Hopefully my indentation comes through right. Otherwise I'll have to adjust it a little bit. So that's not good. Okay, so in this case, if pressure is changing a lot, then you know, you want to put 0.9 comma, you might want to be explicit by saying pressure equals 103.9. Sorry, that should be adjust 3. And we get the same value as before. No surprises though. I mean, whenever we put in the same temperature and the same pressure as function variables, there's no weird stuff going on inside the function that we have to worry about. We get the same value every single time with the same inputs, and that's a nice property of this sort of thing. Okay. And as before, if I do try and access that temperature variable, that was a local variable, no longer works. Pressure, however, since it was defined as a global variable, works. And one thing I'm glossing over is here I have an argument called pressure, but I already have a global variable called pressure up here. So which one takes precedence? Which one is the one that's getting used in the calculation? So I have pressure equals 150. But we saw when I ran this function with 103.9, I got the same result as earlier. So the parameter, the one passed through the parameter takes precedence. It's the one that'll be used, not the global variable. Same with the local variable case. So where is it? Just to right here. I still have a global variable called pressure, but I have a local variable called pressure, and it's set to 103.9. But you'll notice that although the inside the function, there's a variable called pressure set to 103.9 for the calculation. Once we get out of the function, that global variable is the one that has the value 150 still. It didn't get overwritten. So that's something to watch out with scope and variables. So scope is a fancy word for the scope for a variable is a fancy word for what part of the program can see the variable. So for global scope, everywhere, whether it's a function definition or just an open block of code, it can see that variable. For a local variable, it's just the inside the function where it's defined. Its definition goes away at the end. Okay, any questions about scope? Okay, so now we're going to talk a little bit about conditionals. And it's 11:48, so I don't think we'll get any further than this today. We've seen conditionals already, so there's we've seen an if function, so or if block. So imagine that the mass is something that's 3.54. We might see the following: if mass is greater than 3.0, again we put the colon at the end, and that's a cue that we need to indent something. So in this case, we'll print mass, comma, is large. Okay. Similarly, we can do mass equals 2.07. And we can essentially run the same condition. If mass is greater than 3.0, print mass, comma, is large. And this time we run the block, it doesn't run, because 2.0 isn't greater than 3.0. So we have the word if, we have a condition, and then we have the block of what you do if that condition is true. We can get a little bit more fancy. So we can have a loop with a bunch of numbers in it. 3.54, 2.07, 9, 1, whoops, 9, 1, 5. And then we can do our condition as we go through the loop. So for mass in masses, if mass is greater than 3.0, print mass, comma, is large. And so we loop through and we only get two print statements, one for 3.54 and one for 9. So 3.54 goes through, it passes, prints is large. 2.0 goes through the loop. It does not pass, so this print doesn't get done. 9 goes through the loop. it passes this condition, something gets printed, and 1 and 1 and 0.05 don't pass the condition, so nothing gets printed. And we might want to print something for the ones that don't pass too. And so what that might look like is, well what we use is something called an else statement. So we have, okay, if mass is greater than 3.0, print mass is large. Here's what an else statement looks like. So it says, well, if that condition isn't true, let's do something different. So you don't always need an else statement. It's optional. So here's us adding one though, small. So if I run that loop again, I get 5 outputs. So 3.54 is large, 2.07 is small, 9 is large, 1 and 1.05 are also small. So maybe you want to have more than those two conditions. We can use something called an else if, which in Python is spelled elif, and it would look something like this. So if mass is greater than 3.0, print mass is large. Here we go. So I have to unindent and do elif. Oh, I need a condition for elif. Else if the mass is greater than 2, print mass is medium. And then we catch all the other cases with the else, and which requires no extra condition. Say, okay, if it's not greater than 2, not greater than 3, not greater than 2, print mass is small. I can run that block. And I forgot a colon right here. Run it. We get 3 different kinds of outputs. So we get large, medium, large, small, small. Now you gotta watch out for something. Make sure you get these things in order. So I'm just gonna copy and paste this previous code into another cell. And I'm gonna switch up the order. So what if I had said, switch the conditions around. So if mass is greater than 2, print mass is medium. Otherwise, if it's greater than 3, print mass is large. Otherwise, print mass is small. If I run that, we're never going to get any large stuff. So this stuff happens. So conditions are tested once and in order. So the first time through 3.54 is greater than 2. So it runs this is medium chunk of code, and it never gets to this else if mass is greater than 3 bit of code. So something to watch out. You have to structure your conditionals so that the code is executed in the right order. Any questions about that? So when I see some code like this, I feel compelled to, so I'm just copy and pasting it. Copy, paste it. I'm compelled to do something which is called refactoring. And refactoring means rewriting your old code to make sure that it's better. And So the one refactor that I would do here is I'll get rid of this for loop and I'll create a function which we'll call mass category. That sounds like a good name, mass. And now I'll fix this up. So if mass is greater than 3, and instead of printing, what I'll do is I'll say return mass. Else if mass is greater than 2, oh sorry, I'll return large. Otherwise, if mass is greater than 2, return medium. Something else that's interesting is that now I don't even need the else block, because if you're still in the function, you're going to be something that didn't satisfy those previous two conditions. So I can say, I mean, you could put in the else, but you just don't need it, because everything that's left in the function now will be stuff that's small. And now I can do for mass in masses, print mass is mass category mass. So I've cleaned up the code. I've encapsulated the logic of categorizing masses into its own function, and I can run my loop. And it does the same thing as before, just the code is a bit cleaner. And I've used conditionals in this case in my function to return different values from the function. Okay, and so I'll just mention conditionals have ways to combine logic using or and. So we might have another array of values called velocities, and just pick some numbers out of a hat. Make sure it's the same number as before. And we want to loop over both the masses and the velocities. Now it's tricky to do, because if you look at up here, we have for mass and masses, and so mass is always set to a mass. We want to tie each mass in the first list with with a velocity. So the way that you would do that is you'd work with a loop index. So you could do for I in the length of mass. So that's going to be the numbers. And actually, this should be range. Remember our range function gave us the numbers between 0 and a number. So this is going to give us the numbers between 0 and 4. 0, 1, 2, 3, 4 for I. And then we can do mass equals mass is I. The first time when I is equal to 0, that'll give us that 3.54. And velocity is equal to velocities I. So first time through the loop, when I is 0, that'll return this 5.7. And we can do something like, let's see, if mass is greater than 3, and, so here's that and, velocity is, what would be a good test? Greater than 7, do the following, print mass and velocity. So we run that. What did I do here? Oops, I meant to put masses here, not mass. So let's go back. So yeah, just so that I have the masses on the same screen. Let's take a look. So first time through the loop, we get I equals 0, which gives us mass 5.7 and velocity 5.7, mass 3.54. So mass is greater than 3. Velocity is equal to 5.7. So it doesn't match this velocity is greater than 7. So this bit of code doesn't get run. And similarly, the second, when I equals 1, we have mass 2.07, which doesn't satisfy that, so we don't have to look any further. Third time through the loop, mass is equal to 9. That is greater than 3, and velocity is 8.7, which satisfies this other condition. And so we actually print something, and the other ones don't satisfy either. So that's how you can combine your logic with ands. And similarly, you could do an or condition, which will return a lot more stuff. So that's is the mass greater than 3, or is the velocity greater than 7? There's a bunch of cases where both of those situations will pass. Okay, so it's after 12 now. So I think it's time to wrap up. I think I've covered most of what I hope to cover in the course. What questions do people have at this point? Okay, if there aren't any questions, we'll call it done, and I'll just say congratulations. You now know Python, so use your new powers with great responsibility. And yeah, probably next time we do workshops, we'll add another Python course or two, probably one for parallel programming in Python and another one for advanced plotting in Python. So stay tuned for our next workshops, which will probably be in January. And you'll get a survey probably next week sometime where you can provide some feedback. We also will have recordings of these sessions, and you also have links to my notebooks that I've been using if you want to refer to anything that maybe I was going too fast and you didn't include something in your notebook. You can look at my notebook and see what it was that I was doing. I'm going to stick around for a couple more minutes. If there are any questions, feel free to stick around. Otherwise, have a great lunch and have a great time using Python in your work. And if you need some help with Python, feel free to send me an email. You can reach me at research.support@ualberta.ca. Okay, thanks very much.